The Mid-Atlantic Ridge is a spreading center that spans over 10,000 miles around the globe and has an average depth of about 2,500 meters. You can see that it cuts through the Northern Atlantic Ocean, Southern Atlantic Ocean, the Indian Ocean, the Southern Pacific Ocean, as well as part of the Northern Pacific Ocean. This underwater formation was formed through divergent plate tectonic action, where the Northern American and Eurasian plates are moving away from each other. When two underwater tectonic plates move away from each other, new crust is pushed upwards from underneath the seafloor and causes an exposition of magma. In 1872, the HMS Challenger expedition was able to discover the Mid-Atlantic Ridge in Thomson's voyage that traveled over 80,000 miles across the oceans in 4 years. Their discovery also included one of the deepest trenches found along the Mid-Atlantic Ridge, known as the Romanche Trench. This notable component of the ridge creates a separation boundary between the northern portion of the Mid-Atlantic Ridge from the southern portion. This particular trench is 186 miles long and has a maximum width of about 900 miles. It is known to be a relatively narrow yet deep submarine canyon that can be over 25,000 feet deep and holds lots of diverse marine life, such as the sea cucumber. This echinoderm places low on the trophic food web and feeds off of algae and detritus. It is able to do so by first using their tube feet on the sides of their body to burrow themselves into sand or place themselves onto a steady surface. Sea cucumbers use their branching tentacles to grab floating debris or to create a moving vacuum current that can tunnel their desired food into their mouths. The Mid-Atlantic Ridge Ecosystem Project sampled the Romanche Trench fracture zone in 2011 and found an abundance of deposit and suspension feeders. These feeders are able to sustain a wealthy life due to the actions of the microbial loop and hydrothermal vents. The microbial loop demonstrates the amount of primary production occurring in a specific part of the water column. At higher depths, such as the Romanche Trench, there will be a lower F ratio, which means that the microbes and algae living there are able to produce food for themselves through recycled ammonia. According to the Carnegie Institute for Science, ammonia production occurs mainly at hydrothermal vents because the hydrothermal fluid pours out reduced iron, which is used as a catalyst. This allows for lots of diversity at hydrothermal vents. Therefore, one genus of sea cucumber, named Enipneastes eximia, or better known as the headless chicken monster, or even the Spanish dancer, uses a different form of feeding. It has been found at the Romanche Trench, using its unique-looking fins to swim and feed through the water column. Since this genus of sea cucumber has mobility in the water column, it is able to reproduce sexually even though they are not found to live in large groups. If they are unable to find a desired spouse, Enipneastes eximia can release its eggs or sperm into the ocean so that its gametes can travel through movements of the current. I was able to record and create my entire project through my helpful MacBook Air and through SP Adobe Spark, and I would like to say thank you